Hello everyone, my name is Enoch and I'm going to be showing you help and tricks to solve your Math Olympiad problems. Now this video will consist of many topics, but today I'm going to be covering Algebra and Surds. Now there are many questions I would like to show you, but I will decided to split it into a few parts. This is going to be part 1. Now I'm going to be showing you the first thing you must know about algebra. Pascal's triangle. Now Pascal's triangle will help you to solve. Let me show you. Now, how does this Pascal's triangle work? Simple. On the right side, I would always plus 1, plus 1, plus 1. Left side is the same thing. I also plus 1, plus 1, plus 1. Now, numbers like 2 here are the sum of this one and this one. This 3 is the sum of this one and this 2. And this pattern can continue all the way. So you may be thinking, how can this help you? Well, if I were to show you a plus b to the power of 4, it would be equal to a to the power of 4. Now, I am looking at this one here to help. Plus a to the I'm sorry. 4 a to the power of 3 b plus 6 a to the power of 2 b to the power of 2 plus 4 a times 3 b to the power of 3 plus b to the power of 4. Now, you may notice that this one will come here. So this one is followed here. There is a 4 coming here. There's a 6 coming here. There is a 4 coming here. And there is a 1 coming here. Using this theorem, it can help you expand and factorize certain algebraic expressions. Now let's go to the first question. The first question is taken from SMO 2019, question number 14. Now, SMO stands for Singapore Mathematical Olympiad, and I'm going to show you how to solve questions. Here's the first question. Root 199 square plus 800. That is all. Now, if some of you may not know what does this mean, it means I have a same number multiplied by the same number just to give you 199 square plus 800. So how shall we solve this? I am going to use a common number between 199 and 200. Okay? 199, I don't want to use the number 199 because there can be a lot of ways to expand this. But I will use a common number between this and 199 and 800. That will be 200 minus 1 square plus minus 2 times 200 square, 2 times 200 times 1 times 200. So this 200 minus 1 square will give you 199 square. Now I minus off 2 times 200 plus 4 times 200. Now, this is actually 2a times 1, which is b. So, 4 times 200 will make up 800. This 2 times 200, it was already, if I expand it out, sorry for some mishaps. Now, I want to expand, okay, sorry. I want to expand 200 minus 1 square plus 4 times 200. Now, how this would be equal to root 200 square minus, now it is 2ab. Now, a plus b to the power of 2 is equal a square plus 2ab plus b square. So 200 square minus 2 times 200 times 1 plus 1 square. This is already representing 200 minus 2ab. And this would fall with plus 400 plus 4 times 200. So how does this help? I can actually factorize this. I can make this 200 square plus 2 times 200 times 1 plus 1 square. Now, this would fall with a square, 2ab plus b square. Easily, I can make this root 200 plus 1 square. This and this would cancel each other out, which is equal to 201. You may easily type this into your calculator to prove whether this is real or not. I'm going to move to the next question. Now, this is a very similar question. I have taken this question from SMO 2005, question number 2. Oh, one more thing. If you're wondering, this is the junior round. This is also the junior round. Right? Now, here's the question. 0.5 to the power of 3 plus 3 times 0.5 to the power of 2 times negative 1.5 plus 3 times 0.5 times negative 1.5 square plus negative 1.5 to the power of 3. Now, this question is a multiple choice. Let me give you the options. Option A, 1. Option B, negative 1. Option C, 0. Option D, 2. Option E, negative 2. Now, how do we solve this? Now, let's do a few assumptions. Now, just to let you know, A plus B to the power of 3 is equal A to the power of 3 plus 3A square B plus 3AB square plus B to the power of 3. You may derive this from the Pascal's triangle, which I've written down in the previous. You may go back to view it. Now, this question looks very familiar. What if I replace 0.5 is equal A and b, and sorry, negative 1.5 is equal b. Now, when I have negative 1.5 as b, I can already factorize this thing. So I can make this, the equation above, I can make it equal to 0.5 plus negative 1.5 bracket up to a power of 3. Now you may do calculations on your own. So that's just 0.5 minus 1.5 to give you negative 1 to a power of 3, which is equal negative 1. This can be seen as the answer in B.